All right, so we've stated what we're going to do. We've got our planning step completed now. We've checked our 3 conditions. Now we can actually start doing the calculations. So if we're doing a one sample t test, we need to note our test statistic t. So the formula for t is the sample mean minus the true mean, which again, we're assuming the null hypothesis is true. So we're assuming our true mean is 12.1. And we divide that by the standard error. So that's the standard deviation of the sample divided by the square root of our sample size. Cool, so I'm just gonna jot down the numbers we were given. Our sample mean was 12.05, the standard deviation of the sample, and the true mean, as well as the sample size was 4 bottles we check every hour. Okay, so if we throw these numbers into our calculator, we're going to get a t-value of negative 1.176. I'm also going to draw the t-distribution here. So just to double check our math here, we got 12.05 minus 12.1. So that's our numerator there. Divide that by the standard deviation, 0.085 divided by the square root of our sample size. Square root of 4 is just 2, but just to show you where that's coming from. Cool, so t-score of negative 1.176. If we visualize this a little bit, so a t-distribution, it's kind of like a normal distribution, just a little flatter here, especially with a low degrees of freedom. It's going to be a little more squat than the normal distribution, more area on the tails. But at any rate, this t statistic is not very high. Pause this video. Not very high, so we have quite a large area. So I'm a little worried about this. Doesn't seem like it's going to be significant. We can actually calculate the p-value by doing t-CDF. So because it's a two-sided test, we're going to need to double whatever we get from t-CDF. All right, so in my calculator, I'm going to go ahead and go to our t-CDF. We're going from negative big number all the way up to this point here, which is our t-score of negative 1.176. Negative 1.176. Our degrees of freedom, remember degrees of freedom is the sample size minus 1, so we're working with the degrees of freedom of 3. All right, our calculator is going to tell us that the probability of having a sample that low is about 0.16 or 16%. But remember, we're doing a two-sided test, so we need to double that value to account for samples as extremely low or as extremely high as this one. So 0.16 doubled gives us the p-value of 0.324. Great. So we have our probability that we would get a sample this far off if the machine was working correctly. The probability of doing that is about 32%. That's really high. So our p-value being 32.4% is greater than our significance level of 5%. So that means we fail to reject the null hypothesis, meaning there is not significant evidence that the machine is working incorrectly. So basically what we've seen here is that having a sample a little bit lower than what it's supposed to be, 12.05, is pretty probable. Right? There's about a 30. So we draw our conclusion. There's not sufficient evidence that the machine is filling bottles with an average amount different than 12.1 ounces. All right, let's take a look at part B here. So part B says it's kind of the same idea. We're looking at what's the probability of something happening given that a certain condition is true, but this time instead of doing calculations, we're looking at a simulation. So the simulation says that we're going to do 300 simulated samples, all the same size of 4, and these are the standard deviations that come out. So if we look back at our sample had a standard deviation of 0.085, higher than it's supposed to be at 0.05. So if we look at the simulated data, only a few samples were that high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 300 had a standard deviation as extreme as ours. 12 out of 300 is 4%. So 4% is actually lower than our significance level of 5%, which means there actually is evidence that the machine has too much variation